Welcome to this summary of the 2020 activities of the Seagrey Australia Panel C6, Active Distribution Systems and Distributed Energy Resources. The scope of C6 is pretty well summarised by the name. It obviously covers distributed energy resources, that is the connection of large numbers of small generators into the distribution network. However, it also includes storage technologies such as batteries, off-grid systems, electric vehicles and rural electrification. The coronavirus pandemic has meant that C6 has had no face-to-face meetings this year, so displayed is a photo of the C6 members at our meeting in Melbourne last year. An item of good news this year was the elevation of two members to distinguished member status. Ken Ash and Alex Bache have both been long-serving members of C6 and thoroughly deserve their awards. Internationally, Study Committee C6 has published one brochure this year, Technical Brochure 793 on Medium Voltage DC Grid Feasibility Study. This year's regular Paris session had to be replaced by an online event referred to as the E-session. There were 43 papers presented in two dedicated C6 sessions, including 2 papers from Australia. There are an additional 30 papers presented in a combined session between C6 and C2. With regard to upcoming events, the 2020 Paris session has been postponed to 2021 with the C6 preferential subjects as shown on the screen. Much closer to home, we have CIDR 2021 to be held in Adelaide next year. CIDR is the Conference on Integration of Distributed Energy Resources. This will be the 4th time it has been held, following on from events in Brisbane, Sydney and Melbourne. The conference is held over 2 days and has received very positive feedback from past participants. Check the Seagrey Australia website for updates a little bit closer to the event as organisational details are finalised. Further away in both time and distance is the 2022 Seagrey Symposium in Kyoto, Japan. This will be co-chaired by Study Committee C6 as well as Study Committee D2. In 2023, Australia will host a Seagrey Symposium in Cairns. This is a major event on the Seagrey calendar and will attract a number of study committees to Australia. Again, keep an eye on the Seagrey Australia website for updates on the organisational details of this a little bit closer to the event. On the technical side, one of the major issues of interest to members in Australia is the integration of DER. Many of the previous concerns around this have not eventuated. This includes things like power quality, harmonics and flicker, number of tap changes at zone substation transformers, and issues with unintentional islanding. One aspect that continues to be a problem is voltage management in LV networks. However, there are an increasing number of tools available to network owners to mitigate such problems. Whereas in the past, the solution to a voltage problem may have been to upgrade the network, other options available now or that are being trialled include low voltage STATCOMs, voltage regulating distribution transformers, that is distribution transformers fitted with on-load tap changes, and dynamic voltage management systems. PV inverters also include features to help with voltage management, such as the so-called power quality response modes. As problems at the distribution level with integration of PV are being addressed, the sheer quantity of DER installed is starting to create issues at higher levels in the network. This can be seen in differing requirements for rate of change of frequency protection and under frequency protection. From an anti-islanding perspective, the desire is to have tight settings for both these protections to enable fast tripping. However, from a system controls perspective, it is preferable to have looser settings so that DER can stay connected and continue to generate during a system disturbance. One new technology, at least in its utilisation at low voltage, is static synchronous compensators, or STATCOMs. These are being trialled by a number of utilities in Australia, including by Endeavour Energy in New South Wales, who have installed LV STATCOMs at 10 sites. Initial indications from the trial are that they can give a 4 to 8% improvement in voltage and typically provide an improvement of better than 1 volt per kVA rating of the STATCOM. They can also significantly improve phase balance. Another method of managing voltage in LV networks, although across a much wider area, that has been trialled by at least 2 utilities in Australia, is closed loop voltage control. This is the use of the measured voltage at LV customers' premises obtained from real-time meter data to control the set point of on-load tap changes at zone substations. This has the potential to be a very cost-effective way of managing voltage and thus increasing DR hosting capacity of networks. The use of community energy storage, where a DNSP, possibly in conjunction with a retailer, installs battery energy storage within their network, continues to be trialled. Western Power in Western Australia has installed 13 sites to date with good feedback from the community. Trials are also being undertaken by a couple of other utilities in Australia. Another development, which is expected to continue to expand, is to disconnect fringe of grid customers from the power grid and install standalone power systems instead. This can give lower costs, improve reliability, and increase customer satisfaction. This has been trialled by Western Power with good results. A number of other utilities have also conducted limited trials, although there continue to be regulatory issues which need to be overcome. Thank you, and that concludes this presentation.